so here's the stuff for quiz 13.1-13.4. So, classic trig, given a triangle like this, and given that this ratio is positive, what we would do is we would draw a triangle. Since the sine ratio is positive, we draw a triangle oriented in quadrant 1. Now, the theta always goes near the origin, and the sine ratio is opposite over hypotenuse. If you still haven't learned how to spell SOHCAHTOA, it's about time to do it. The year's almost over. So anyways, let's take the fact that sine is opposite over adjacent, and let's put some stuff, opposite over hypotenuse, and put those sides on the triangle. Now, this little side right here is going to be needed for tangent, because tangent is opposite over adjacent. So I'm going to have to do some, I'll call this little guy right here A. A squared plus 3 squared is 8 squared. So A squared is going to be 64 minus 9, 3 squared is 9. And that'll give me what? 55? So A is going to be the root of 55. Seems right. Square root 55. Now the tangent ratio is opposite over adjacent. So the tangent of theta, since it's opposite over adjacent, is 3 over root 55. And we clean that up by multiplying the top and bottom by a root of 55. And we get 3 roots of 55, sitting pretty over a 55. Ta-da! Alright, another one of these. Here we're given 2 things, and there's lots of ways of doing this one. Lots and lots and lots of ways of doing this one. You could kind of do the same thing and draw a triangle. Put beta. Sine ratio is going to be root 33 over 6. Remember, sine is opposite over hypotenuse. So root 33, hypotenuse 6. And cosine is adjacent over hypotenuse. I've already got the 6. And, oh, I didn't even think about orientation. Well, anyways, negative root 3 there. Find the tangent. Well, you know as well as I do that tangent of an angle, and this one's beta, is opposite over adjacent, so it's going to be root 33 over a negative root 3, which is a negative root of 11. So that's one way of doing this. Another way is to just fall back on something that I have shown you, that the tangent of an angle is the sine of the angle over the cosine of the angle. So the sine was root 33 over 6, and the cosine was given as negative root 3 over 6, and things in corresponding places cancel, and we get root 33 over a negative root of 3, and again, the reason this is root 11 is because we can take 2 square roots and we can kind of merge them. 33 over 3 is 11, and the negative symbol moves to the numerator. Not a hard problem. Let's see here. Angle theta drawn in standard position intersects a circle with a radius equal 8 at the point root 39 and negative 5. And by the way, this is x and this is y. Find the secant of alpha. So from your circle quizzes, the secant of alpha would be r over x. No? Yes? Yes. And the radius is given as 8, and the x-coordinate's root 39. And of course, we clean that up by multiplying the numerator and denominator by root 39. And we get 8 roots of 39, sitting pretty over 39. Ta-da! Moving forward. Theta being drawn in standard position intersects the unit circle. The unit circle, which means that the radius is 1, at negative 1/4 and negative root 15 over 4. Evaluate the sine, cosine, and tangent. And by the way, you have an ordered pair, and ordered pairs possess x's and y's. So from your little circle quizzes, you know that the sine of an angle is y over r, psi y. So it's going to be negative root 15 over 4, and that's all over a 1, so it's just negative root 15 over 4. On unit circle, sine is just the y-coordinate. The cosine of the angle is going to be x over r, and the x-coordinate is negative 1/4, and it's over that 1, but so just negative 1/4. And finally, the tangent of an angle is defined to be y over x. So it's going to be negative root 15 over a 4 divided by negative 1/4. And a negative over a negative is a positive, and the 4's cancel out, and you're just left with a root of 15. Easy problem. It's one of the easiest problems on a whole blasted quiz. It has a high high miss rate historically. Maybe y'all will be better. But then again, it's the end of the year and you really don't care. Standing on a building 2,200 feet tall, you look down at a car. So there's a building that is 2,200 foot tall. You are looking down at a car. Buildings usually form right angles with the ground. And you're looking down. We're not going to talk about how tall you are. But it talks about the angle of depression. Angles of depression are formed with the horizon. If you don't believe me, go ask your geometry teacher. They're not inside the triangle. But the angle with the horizon measures 68 degrees. Now, you should have had a lesson about this and why it works the way it is, but they are equal to the angle of elevation. It has to do with the parallel lines and such as that and altered interior angles. So I can actually put 68 degrees right there. Question is, how far is the car from the building? We'll just call that X, and then we'll assign some ratios here. This is the opposite side, and this is the adjacent side, which is the tangent ratio. So therefore, the tangent of 68 degrees is going to be 2,200 over X. We shall cross multiply. X tangents of 68 degrees is 2,200. And then we shall isolate X through division. So X is 2,200 divided by the tangent of 68 degrees. Now on quiz day, please, please, please make sure that your calculator is in the correct mode. That burned some of y'all last time. I am going to feed tangent a degree, so I had better make sure that my calculator is in degree, and mine was not. So, switch over. Anywho, 2,200 divided by the tangent of 68 degrees shall be 888 point, let's just say 889 foot, because it's a real world problem. It's close. It's about 889 feet. Number 6, convert negative 2.49 radians into degrees. You just need to know a simple formula. If you don't know the formula, well, then I guess you're up a creek without a paddle, so to say. So we're going to multiply it by 180 degrees divided by pi. It's never too late to pass, and it's never too late to fail. Most kids fail because they're not here and then they never make anything up. Negative 142.67 degrees. I usually take these out to the nearest hundredth. There we go. Easy peasy lemon squeezy. All right. Let's consider a 6-bladed wind turbine with blade lengths of 75 foot. So there's a turbine here. It's got 6 blades. Let's start off by making it 3, and then we'll split it again. There we go. There's my turbine. Find the length of the arc between each blade. So if it was moving, they would want to know that, okay? So I took a circle, you can kind of see me outlining a circle, and I split it into 6 equal parts. So if I take 360 and divide it by 6, I get 60 degrees. The separation between each blade is 60 degrees. Now I know, and you know, that 60 degrees is going to be pi over 3, and that's important. Because the formula for arc length is SRT, or S is R theta, right? And theta has to be a radian. So that's why it's important. The blades were 75 feet long, so that's the radius of a imaginary circle. And the angle is pi over 3. And we just do 75 times 3. 75 over 3 is 25. We get 25 pi foot. And let's see what that is roughly. You know, be prepared for either answer. 78.54 foot. Find the area in between each blade. So again, we're just going to use our formula for area. The area of a sector is 1/2 r squared theta. And I'm not giving you this stuff. I'm not doing it. Radius is 75. Square it, theta being pi over 3. Let's see what it looks like in pretty form. 0.5 times 75. That guy's got to be squared. And then we got 1 over 3. Pi over 3. Convert it to a fraction, make it pretty. 1875 over 2. Don't forget about the pi or the square foot. And again, make sure you understand both. See what it looks like with a pi. Real world comprehension. 2945.24. Square feet. All right, number 8, evaluate the cotangent of 5 pi. So this is a unit circle concept, 100% unit circle concept. 5 pi, if you rotate once is twice pi, twice would be 4 pi, and then you have a pi left over. So what you can do is you can make your thing smaller by taking away 2 pi. And you're going to work with the cotangent of a singular pi because it's in the same exact spot. And this is mainly for y'all to understand what's going on. I don't have time to draw the full unit circle, but you're more than welcome to on quiz day. That's up to you. But pi is going to be right here. And the ordered pair there is -1, 0, and that's where pi is, and it's also where 180 degrees is, okay? And, if you think about your little boxes off to the side on your little circle quizzes, somewhere it says the cotangent of theta is x over y. And I know that's what it says. It says the cotangent of theta is x over y. So here's x, here's y. This is going to be -1 over 0, which is undefined. Undefined. Find 2 angles coterminal with 11 degrees. I'll probably make this multiple select. That would be my guess. It really would be. You can do 11 degrees plus 360 degrees, and you get 371. You could add 360 again to that, and you get 731. And, you could add it again if you wanted to, and you get 1,091. And that's if you work forward to some degree. Or you could do 11 minus 360, which is -349. And you could take it away again, which is -729, I believe. That's not right. -709. And you could just keep going. But the idea is you just add or subtract 360. Nothing more, just plus or minus 360 until you find something. All right, here we have a select all, which angles are coterminal with 21 pi over 4. And it's really as simple, since we're talking about pi rads, as doing plus or minus 2 pi. So I feel like doing this old school. I would do 21 pi over 4 plus 8 pi over 4, because 8 pi over 4 is 2 pi. And I would get 29 pi over 4, which is not an answer. Well, it is an answer. Sweet. Now, I can add 8 pi over 4 again to that, and I would get 37 pi over 4, which is another one. And I don't see anything bigger than 37 pi over 4, so I'm going to stop. Now, I'm going to go the other way. I'm going to do 21 pi over 4 minus 8 pi over 4. And 21 minus 8, last I checked, was 13. So 13 pi over 4, which isn't on there. But it doesn't mean I stop. I can still take away another 8 pi over 4, and 13 minus 8, last I checked, was 5. So there's a 5 pi over 4, which is right there. And I see another one, because wait, there's more. 5 pi over 4 minus 8 pi over 4 is -3 pi over 4, because 5 minus 8 is -3. There you go. I know some kids get confused in the basic arithmetic. I don't know why they're letting you proceed when you can't add or subtract. It doesn't make any sense to me. Part of your issue is you don't realize what 5 minus 8 is. I mean, you never stood a chance. Using reference angles in the 30, 60, 90 pattern, evaluate the cosecant of 11 pi over 3. All right, So this one again, the angle is not something I care to graph. And I'm not gonna run through like I did last time, because we have a faculty meeting coming up. But we're gonna take away 2 for a while. This isn't bad. You know, that's 5 pi over 3, which I know is on the unit circle. So that's what I'm gonna work with. It's 5 pi over 3, and I know that that is 300 degrees because I memorized the unit circle. So it's a 300-degree angle. All angles start on the positive x-axis, and they rotate to a terminal side. Now this one has 60 degrees remaining to get to the nearest x-axis. This little guy right here, that's what you call that reference angle. It's the angle formed with the closest x-axis. And we're just going to triangle it out. The day I did these notes, I used this pattern, 30, 60, 90. I did 1, 2, root 3. Also remember ASTC. If I want cosecant and I'm in quadrant 4, cosine and secant are positive. So my answer is going to be negative. My final answer had better be negative. That's great test taking stuff. So anyways, opposite of a 60 degrees is a root 3. Direction makes it negative. Adjacent to a 60-degree angle is a 1. And then we have a hypotenuse of 2. So when I talk about the cosecant ratio, going back to the original angle here, cosecant's a hoe. We've been over that. Hypotenuse is 2. Opposite's negative root 3. And we'll clean that up by doing root 3 over root 3, technically negative over negative. So negative 2 root 3 over 3. Now, Mr. Milbrath, is there another way to do this problem? Of course there is. Of course there is. 300 degrees was on the unit circle. It was right here. And the ordered pair was 1/2 root 3 over 2. And this was negative. Now, the radius of the unit circle is 1. If you glance off to the side there in that little box, it talks about the cosecant of an angle with the circular approach. Okay, the circular approach being y over r. So I could have done this. I could have done, sorry, not y over r, r over y. I could have done 1 over, that's supposed to be a y, negative root 3 over 2. And I am dividing by a fraction. This would have become negative 2 over root 3. Clean it up, root 3 over root 3. And got negative 2 root 3 over 3. So there's still the circular approach. Now, I really don't care on test day what you do. I really do not. You pick your poison. All right, using reference angles and the 45, 45, 90 pattern, evaluate the cosine of 21 pi over 4. And again, that's an angle I don't really care to do a whole lot with. Change it to 5 pi over 4 because that's what it is. And 5 pi over 4 is 225 degrees, which, by the way, is also on the unit circle, right? It's right here. You got the ordered pair negative root 2 over 2, negative root 2 over 2. And the cosine of an angle is x over the radius, which is 1. So think about your circles. You can still get the right answer just with the circle. Anyways, I'm going to write 225 degrees, which is going to put me about right here. And that last bit of rotation was 45 degrees. Kind of small there. And when I taught this lesson of the, this was 13.3, trig ratios of any angles, I did this pattern right there. So opposite's a 1, direction makes it negative. Adjacent is a 1, direction makes it negative. Hypotenusi are always positive. And the cosine ratio is adjacent over hypotenuse. So adjacent's a negative 1, hypotenuse is root 2. I multiply top and bottom by root 2, and I get negative root 2 over 2, which you'll notice is exactly what you have right there. Connect dots, kids. Unit circles way quicker. 13, using reference angles and the 30, 60, 90 pattern, evaluate the sine of negative 120 degrees. So it's going to rotate 90 and 30 more. It's going to look like that. But the reference angle is the 60 degrees that remain to get to the nearest x-axis. And again here, opposite's a negative root 3 because of direction, adjacent is a negative 1, hypotenuse is 2. And the sine ratio is O over H, so it's going to be negative root 3 over 2. And I'm not trying to waste your time, but I'm trying to mention these things. 120 would be right here on your unit circle, which is 240 degrees. And the ordered pair there is negative 1/2, negative root 3 over 2. And off in that little box over there, it says the sine of an angle is y over r, and the r is 1. So it's going to be this guy over 1, which is that guy. 14, find the measure of angle A and B in the triangle below, round to the nearest 10th of a degree. So I'm going to focus my attention on A. If I'm looking at angle A, this 13 is opposite and this 18 is adjacent. So I know that the tangent of angle A is 13/18. Now, tangent finds side lengths. Angular tangent or arc tangent finds angles. Therefore, the measure of angle A is not the tangent of A, but it is the arc tangent of the ratio 13/18. The inverses find angles, kids. Second, tan brings up the inverse function. Now I am in degree mode. Okay, it's 35.84 degrees. All right, for angle B, it's still going to be the tangent ratio, but when you look at B, these guys swap places. This becomes adjacent and this becomes opposite. So when we talk about angle B, the measure of angle B is the arc tangent of 18/13. And let's see here. Hopefully it's the same as 90 minus. All right, check this out, in case you kind of stunk at geometry. There's 90 minus. Arc tangent of 18/13, it better be the same thing. It is, it's 54.16 degrees. All right, now we get to the fun stuff. Evaluate the arc tangent of negative 6.45 such that the angle lies between 0 and 180 degrees. So this is where it gets fun because calculators tell half-truths. At least with trig, okay? You've also got this to back it up, ASTC. There's two places tangent's negative, here and here. That's where tangent's negative, and this is negative. The calculator only gives me an answer here, but when I talk about being between 0 and 180 degrees, that means I'm going to be in quadrant 1 or quadrant 2, and it's going to be, the angle lies here, and this is the hard part about this stuff, realizing it. Calculator tells you how half-truths. So if I go to my calculator and I hit second tan, negative 6.45, it's going to give me an angle in an undesirable area. It's negative 81.19 degrees. Which rotates like that. That's the wrong color. It's also in the wrong place. So what we do is we use something called vertical angles. I don't know if you remember it or not, but if there's an 81.89 degree angle here, there's an 81.89 degree angle there by vertical angles. Now the actual angle that I want, theta, is the straight angle of 180. Take away the reference angle of 81.89 degrees. So we got 180. In this case, since that's negative, plus 98.81 degrees. Now, I know this is just bothersome, but, and I get why kids don't like it. It has to deal with just not memorizing things. This should be 6.45, or negative 6.45, and it is. So the correct answer is about 98.81 degrees. Lots of little things going on in trig. And if you've been struggling so far, like you ain't seen nothing yet, I mean, I'll show you 5% of trig. That's it. That's it. Like, you're not even gonna see all of trig. All right, evaluate the arc sine of negative root 3 over 2. So what this is saying is what angle has a sine ratio of negative root 3 over 2. So on the unit circle, sine is the y coordinate. Sine's the y coordinate. So I'm thinking about where all I see these negative root 3 over 2's. And I know I see them down here, okay? I see them here and I see them here. Because right here there is a negative 1/2 negative root 3 over 2. And right here there is a 1/2 negative root 3 over 2. Now, what angles have those numbers? 240 degrees is one of them and 300 degrees is the other one. So the correct answer to these is going to be 240 and 300. Now, the unit circle is so much better. If you go to the calculator and you type this in, it's not going to give you the answers I gave you. In fact, it's only going to give you one answer, and it's going to say negative 60. And negative 60 is right there, which is the same exact spot. It's the same location, but different rotation as 300. So the unit circle is really where it's at. The unit circle helps you realize that there's two answers to these things, and it does things that technology cannot do. 17, given the tangent of alpha is negative x, and alpha lies in the fourth quadrant, find the sine of alpha. So we're just going to draw a triangle in quadrant 4, drawing the way I always do, right angle with the x-axis. Alpha here, even though it's going to be a reference angle, but it's okay, it's still alpha. Call it alpha prime if you want to feel better about yourself. And the tangent is opposite over adjacent, and every number in the universe exists over 1. So we have a negative x for opposite, a 1 for adjacent. We do a little Pythagorean theorem to get that hypotenuse. So x squared plus 1 is c squared, which means x squared, the root of x squared plus 1 is c. Now, find the sine of alpha. Sine is opposite over hypotenuse, so it's going to be negative x over root x squared plus 1, and there's nothing you can do with that one bit whatsoever. I have 3 minutes. Alex props a ladder against a wall. The ladder makes a 27-degree angle with the ground. Ladder's lean, by the way. 27-degree angle with the wall. The ladder is 22 feet long. Find an expression for finding the distance the foot of the ladder is from the wall. So they want this. How far is the ladder from the wall? That is adjacent to the 27-degree angle, and this is the hypotenuse. That's the cosine ratio. The cosine of 27 degrees must be equal to x over 22. Therefore, through cross multiplication, x is 22 cosines of 27 degrees. Oop, that one. And the last official question, because the other two are bonuses, and I'm out of time. So anyways, write the inverse of h of x equals 3 tangents of x minus 2. To write an inverse, we swap x and y. We've done these things. So this becomes x, and it would be equal to 3 tangents of y minus 2 plus 5. We do the easy things first. The easy thing you can do here is subtract 5 from both sides. And the next easy thing you can do is divide by 3. What you're going to do is you're going to isolate the tangent function. Okay, so I went through all that to isolate tangent.
Teachers, please be making your way.
Now, opposite of tangent is arctangent. So we take the arctangent of both sides. I have a faculty meeting. Oops, that should be arctangent of the tangent of y minus 2. And those guys knock each other out. And the last thing to do is to add 2. So the arctangent of x minus 5 over 3 plus 2 is my y. Whew. Just barely made it. Anyways, there's your twin. The last two are bonuses. I'll put them up later.